Welcome to this explainer. Today, we're diving straight into the absolute weirdness of why we dream. We're going to be pulling from the latest sleep research, some wild historical anecdotes, and evolutionary biology to figure out exactly what's going on in our heads when the lights go out. And we're starting with a question that, honestly, you probably never even knew you had.
Picture this, a tiny jumping spider just dangling by a silk thread in a dark laboratory at night. It's perfectly still, just resting. But what could possibly be going on inside its tiny little arachnid head? For the longest time, we kind of just assumed that complex dreaming was a uniquely human thing, or, at least restricted to mammals. But when researchers started looking really closely at these spiders, they noticed something absolutely wild.
Well, get this. They actually experience REM sleep. Scientists at the University of Constanza were able to observe these spiders through their translucent exoskeletons. And every so often, the sleeping spider's legs would curl, its spinnerets would twitch, and, this is the craziest part, the retinas of its eyes would dark back and forth super rapidly. It looked exactly like human rapid eye movement. REM sleep. So it turns out, complex sleep is definitely not just a human thing. Take zebra finches, for example. Their brains light up in the exact same neural sequence when they're sleeping as when they're actively singing. They are quite literally dreaming of practicing their songs. And then you've got marine mammals like dolphins who use unihemispheric sleep. That means they literally sleep with only half their brain at a time, so they don't drown. It just goes to show, sleep and dreaming, it's a fundamental biological imperative across the entire animal kingdom.
Section 1. Dreaming in black and white. You know how our brains are basically like giant sponges? Well, how they build our nightly simulations depends heavily on what we actually feed them during the day. Researchers discovered something pretty mind-blowing. Watching black and white television literally programmed older generations to dream entirely in grayscale. Because we're so used to wildly colorful media today, we just kind of assume dreams are always like a vibrant YouTube video. But people born before color TV, they actually had monochromatic dreams. The media didn't just entertain them, it fundamentally changed their brain's rendering engine.
Now compare that to folks who are blind. Their dreams naturally adapt to be incredibly rich in sound, touch, taste, and smell. If someone is born blind, their brain doesn't waste any processing power trying to generate visual imagery it's never experienced. Instead, the brain perfectly tailors our nightly simulations to the sensory inputs we actually use in real life. It just proves that a dream isn't some rigid, pre-recorded movie playing in your head. It's a completely dynamic, customizable virtual reality.
But that brings up a good question. Why do we only remember certain dreams when we wake up, while the rest just vanish? Well, as sleep researchers point out, we usually only remember the bizarre or highly emotional ones. Think about it. Just like in your waking life, you tune out what you expect to see. A boring, regular yellow banana in a dream, that fades from your memory instantly. But if your brain hands you a neon pink banana, that emotional surprise makes a real impact, and it sticks with you straight into the morning.
Section 2. Dreams that changed history.
So these bizarre, emotionally charged nighttime hallucinations, they aren't just biological static or background noise. They're incredibly functional. In fact, they've actually helped invent the modern world. Take Mary Shelley. She experienced this terrifying waking dream of a pale student assembling a hideous human figure, and boom, she turns it into the classic novel Frankenstein. Then there's the chemist Dmitry Mendeleev. He spent 3 grueling days awake trying to organize the chemical elements like some frustrating game of solitaire. He finally crashes, falls asleep, and in his dream, a multidimensional, perfectly organized grid appears where every single element just falls right into place. He woke up and literally wrote down the periodic table. And hey, it happens in tech too. A 22-year-old grad student named Larry Page had a wild dream about downloading and saving the entire World Wide Web purely by organizing its structural links. He woke up, grabbed a pen, and wrote the exact algorithm that became Google. These massive, world-changing ideas were all pulled directly from dreams.
Section 3. The science of why. Okay, so why? Why does the brain completely disconnect from reality and do this to us every single night? What's the actual biological utility of hallucination? Let's look at the leading theories, starting with the threat simulation theory. This idea basically proposes that your brain is acting like an ancient evolutionary VR simulator. It intentionally forces you to practice escaping danger, whether that's running from predators or just navigating awkward social rejection, so that when you face those actual threats in the waking world, your reflexes and emotional responses are already primed. Your brain is essentially giving you a safe sandbox to practice survival.
On the flip side, we have the activation synthesis theory.
This one takes a slightly more mechanical approach. It says that during REM sleep, your brain is just highly active, firing off totally random electrical impulses that pull disjointed imagery and emotions from your memory banks. But because the human brain is an absolute master at storytelling, it acts kind of like a librarian stumbling around in the dark, desperately trying to weave all these chaotic random sparks into one logical narrative. In this view, the dream is really just the brain trying to make sense of its own nightly routine maintenance.
But then there's this newer, incredibly compelling concept called the overfitting theory. And this actually borrows an idea straight from artificial intelligence. In AI, if you train a computer model on the exact same data over and over again, it becomes overfitted, which basically means it gets way too rigid and completely fails when it encounters new, unexpected situations. The theory suggests the human brain faces the exact same problem. Our daily routines are super repetitive. So to keep our minds sharp and flexible, the brain deliberately injects weird hallucinatory randomness into our sleep.
And I bet a lot of you have actually experienced the evidence for this firsthand. It's called the Tetris effect. If you play a repetitive game like Tetris for hours and hours, you will almost certainly close your eyes and dream about falling blocks. That is your brain actively recognizing a rigid, repetitive pattern and intentionally scrambling the data to run a nightly software update. Dreams rarely just replay our memories perfectly. They present us with strange, corrupted versions. And doing this forces your brain to generalize what it learned and significantly enhances creative problem solving, which, by the way, is exactly how folks like Dmitry Mendeleev and Larry Page found their massive breakthroughs.
And this brings us to probably the most profound takeaway from all this latest research. To use the exact words of the scientists studying this, it is the very strangeness of dreams and their divergence from waking experience that gives them their biological function. The hallucinatory weirdness of your dreams isn't just some glitch in the system. The weirdness is the entire point. It is literally the mechanism that stops you from becoming a rigid and flexible robot.
Which brings us to the end of our explainer. Your brain is a masterful, hyper-creative engine that spends an entire third of your life running bizarre, colorful, grayscale, or even heavily scented simulations, all just to keep you sharp, safe, and wildly innovative. So as you drift off to hit the pillow tonight, ask yourself, what bizarre connections is your mind about to make, and what complex problem is your brain trying to solve for tomorrow? Sleep well and let your mind wander.